All right, today's notes are short and sweet. They are on incomplete dominance and codominance. So please grab your guided notes sheet so we can go ahead and get that filled out. The objective for today is to be able to define incomplete and codominance and also be able to complete Punnett squares that exhibit these types of dominance. So incomplete dominance we'll talk about first. Every genotype has its own phenotype. So this is different than what we've talked about before because big H and big H little h used to be the same phenotype, but now we're saying that big H would have a different phenotype than big H little h. So the heterozygous phenotype is a blending of the homozygous parental traits. So if you had big H was long hair and little h was short hair, big H little h would be medium hair. Of course, it's not as simple as that, but that's basically what we're talking about. So heterozygous phenotype is a blending of the homozygous parental traits. So we say the heterozygous phenotype blends the homozygous phenotypes. So an example of this is flower color in snapdragons. You could have a red snapdragon or a white snapdragon. Red would be big R, white would be little r, and then the pink offspring would be big R, little r. Notice that they are the heterozygous genotype, and they have their own phenotype, which is pink. So go ahead and pause the video and complete the table. Remember that your genotypes are your letters and your phenotypes would be your flower color. All right, so now we'll do a sample problem. A white flower and a pink flower. So the white flower genotype, what is it? And write that on the top of your Punnett square. The pink flower genotype, what is it? Write it on the left side of your Punnett square. And then go ahead and fill in the Punnett square boxes within the Punnett square. Now I want you to look at your genotypes and to figure out what the phenotypes are. How many red flowers do you have? How many white flowers do you have? And how many pink flowers do you have? Okay, so from here, you should have had a Punnett square that looks like this. The top is your white, little r, and your pink is big R, little r. You end up with 0 red, 2 white, and 2 pink. The little r's are your white, your big R, little r's are your pink. Okay? So we will do more practice problems on incomplete dominance in class tomorrow. So now for codominance. Every genotype has its own phenotype, just like in incomplete dominance. However, in the heterozygous phenotype, both alleles are expressed. So going back to my horrible hair example, if you have long hair and short hair, you would have long hairs and short hairs. So the result is the heterozygous phenotype shows both traits. So one example we see in real life is chicken feather color. Okay, so you have a white chicken, a black chicken, or a black and white chicken. Okay, if we use the same alleles that we did before, like the pattern, we could use B's. So big B could be white, little b could be black, and the heterozygous big B, little b would be black and white. However, I want to show you 2 more ways that we write alleles for incomplete and codominance. You just have to pay attention and adjust to whatever the author of the problem is trying to get across. Different textbooks and different teachers use different alleles. Another way you could do this was WW for white, big B for black, and then BW for black and white. Or another way you could do this would be big B for white chickens, big B prime for black chickens, and then big B prime for black and white. So again, just pay attention to whatever's going on with that. In the end, you should know if it's codominant because the heterozygous will exhibit both of the traits, and incomplete dominance would be a blending of the traits. Okay. So here, go ahead and take a minute and fill out your table for the chicken color. And I'll go ahead and go back one. Are you going to use the top line, the middle line, or the bottom line? Doesn't matter. All right, and then the sample problem for codominance. So cross a black feathered chicken with a white feathered chicken. So put your black feathered chicken genotype on the top of the Punnett square. Put the white feathered chicken genotype on the side of the Punnett square and complete the Punnett square. Okay. So what did you get? How many are black? How many are white? How many are black and white? All right, so this is your black chicken on top. This is your white chicken on the side, and everybody ended up black and white. So 0 black, 0 white, and 4 black and white feathered chickens. So you've done this in, outside of class, and then when you come back to class, we're going to work some examples together to make sure that we all can understand it and then move on from here. Thank you and have a good night.